Hello everyone, welcome to a Small Turbo YouTube channel. Today we're going to discuss about evaluation of algebraic expression. In this lesson, you will learn how to substitute values in an algebraic expression. Before we go further, let us review the following. We use GEMDAS in solving series of operations. It stands for G grouping symbols such as parentheses, brackets, and braces. E stands for exponent, M for multiplication, and D for division, A for addition, and S for subtraction. On the other hand, in this expression, M cubed, or M to the power of 3, M is the base and 3 is the exponent. This time, you will do the same thing in our lesson. You will simply substitute all the variables with their corresponding values and solve using GEMDAS rule. This is called evaluation of algebraic expressions. So again, when you say evaluation of algebraic expressions, all you have to do is to substitute all the variables with their corresponding values. Let's have the following examples. Without much further delay, let's have example number 1. Evaluate 6b plus 4b if b is equal to 3. So what could be our solution? It seems that it looks so hard, but actually it's just very easy. So for the solution, all we have to do is, first is you copy the given algebraic expression. So it is given that b is equal to 3. So all you have to do is substitute all the variable b with 3. Since there is no plus or minus between 6 and b, in the given, the same with 4 and b, that means the operation is multiplication. Again, if there is no plus or minus in between that, here, that means that the operation to be used is multiplication. Hence, 6 times 3 plus 4 times 3. So instead of writing b besides 6, instead of writing b, we are going to substitute with the value of the b, which is 3. And yes, the same with the letter b beside 4. We substitute it with the value 3. So we use parentheses instead of the symbol x to denote multiplication, to avoid confusion, because this time we are dealing with algebraic expression and x is a variable in algebra, so we may use like this parenthesis or the dot as multiplication symbol. So in GEMDAS, multiplication comes first than addition, so we will multiply first before we add their products. So the product of 6 and 3 is 18. Copy the plus sign. 4 times 3 is 12. So the sum, after you simplify, you're going to add 18 plus 12. That is 30. Okay? So always remember to follow the GEMDAS rule after you substitute the variable with its corresponding value. So look at these expressions which are almost the same. Okay, let's have the second example. 5m minus 7. Okay, and the third example is like this: 5 times m minus 7. Suppose m is equal to 2. So let's try to evaluate. Let's try to see if they have the same answer. Example 2 and number 3, it looks like seems that they are the same, but let's try to see if they have the same answer. So in the given, example number 2, if m is equal to 2, then find the corresponding value of 5m minus 7. So the same with example number 1. First, we will again copy the given algebraic expression. Then we will substitute the variable by its corresponding value. So instead of writing m, we are going to put in here the value of m, which is 2. Then, again, there is no plus or minus between 5 and m in the given. Thus, it means that the operation is multiplication. That is the reason why we enclose 2 with parentheses, because parentheses is a symbol of multiplication besides the dot. So here, 5 times 2, that is 10. Then copy the minus and the 7. So 10 minus 7, that is 3. So just recall that the GEMDAS rule. Okay, then so remember that the answer here for number 2 is 3. Let's try to take a look at example number 3. Evaluate 5 times m minus 7 when m is equal to 2. Okay, so we simply substitute m with 2, but this time 2 is inside the parentheses together with 7. So, as you can see in the given, there is no plus or minus between 5 and m here, or 5 and m minus 7. So, it means the operation between them is multiplication. Okay, between 5 and m minus 7, multiplication. So, we need to solve first the expression inside that grouping symbol, which is parentheses, before we multiply it by 5, because in GEMDAS rule, grouping symbol comes first, then multiplication. Thus, you're going to simplify first the one inside. 2 minus 7, the answer is negative 5. You need to apply here the rules in subtracting integers. Recall your discussion in quarter 1. So take note, 2 minus 7. So the rule in subtracting integers, you're going to change the sign of the subtrahend and proceed to addition. This time, you're going to have 2 plus negative 7 is equal to negative 5. So the last operation left is multiplication. Simply multiply 5 and negative 5, and the result is negative 25. Apply here the rules in multiplying integers, which is the product of two integers with the same sign is positive, while the product of two integers with different signs is negative. So here, positive 5 times negative 5, you have the answer, which is negative 25. So notice the answer in example 2 is 3, and here example 3 it's negative 25. So 5m minus 7 and 5 times m minus 7, this example 3, may look like the same, but because of the grouping symbol, they are actually different when you evaluate it. Okay, then we have, so before we proceed to the next example, always take note of the GEMDAS rule, because a little difference in the given can change the result. So this time, in the next example, what if there is an exponent in the given? So we are going to have the exponent here. So Evaluate 4r squared plus 5r when r is equal to -3. So just copy the given algebraic expression. So we will just substitute all r's with -3. Then check the operations. In the given, there is an exponent. So a small number at the upper right, this one, which is 2. We also have multiplication and addition, but using Gemda's rule, exponent comes first, then other operations. So let us solve first the exponent. We need to multiply -3 times -3, or we need to multiply -3 twice or 2 times by itself. That's -3 times -3, because the exponent tells how many times you will multiply the base by its exponent. Next, the product of -3, okay, the product of -3 and -3, -3 and -3 is +9. Also, the product of 5 and -3, it's -15. So we just copied, okay, we just expand the -3 here. Instead of writing -3 to the power of 2, we just write -3 times -3. They are just the same. We just copy 4 here. Then after that, just recall the rules in multiplying integers, which is the product of two integers with the same sign is positive, while the product of two integers with different signs is negative. So just copy 4, -3 times -3, that's +9. Copy the plus sign. 5 times -3, that's -15. That's the rule. Positive and negative multiply, the answer is negative. Then, alright. Okay, then we have 4 times 9 plus -15. So 4 times 9, that's 36 plus -15. So when you add different signs, so you are going to get the difference. Then follow the sign of the greater number. So the answer is +21. Okay, next example. Let's have the next example. What if we have more than one variable? Like, okay, so let's have example number 5. Evaluate 8v plus 3 times 2w minus v when v is equal to 5 and w is equal to 4. So it seems again very hard, but actually it's just very easy. Okay? So here, okay, having more than one variable follows the same steps. Okay, again, the same steps. First, substitute the variables with their corresponding values. Then, substitute, instead of writing v, you're going to substitute it with its value, which is 5, and w, the value for w is 4, given in the previous slide. So we use that here as multiplication symbol between 2 and 4. So using Gemda's rule, we need to solve first the grouping symbol before we multiply it by 3. So you just copy here 8, 5 plus, so 8 times 5, that's 40. Then just copy the 3. 2 times 4 is 8 minus 5. Just copy the 8 then minus 5. And then you write the 8 here, then minus 5. Alright, then copy 40 plus 3 times 8 minus 5, that's 3, that's 9. So 40 plus 9, it's 40. So very easy, right? So this time, it's your turn to evaluate an expression. And thanks for watching. So you may open your SLHT for your own exercises. Bye-bye!